All right. Yes, we're in the packet tracer because it's the quickest way to show you this. Okay. What we're going to talk about now is the designated router and backup designated router. Okay. It is important you understand what they are, how it's elected, and how to look for it. All right. And where does it occur? This election process. Let's do the easy stuff first. That's why we have these two right here. You have the identical same two routers with just the difference. This is an Ethernet cable and this is a serial cable. All right. So let's take a look at the serial cable. Let's see who's the designated router and backup designated router is. So we're going to go inside this router right here, router 4. Let's put it on this side. All right. No, we don't want that. We want this. All right. And then we're going to do enable. Oh, we can do it from right here. We can do a show IP interface. No, show IP OSPF interface S0/0/0. Show IP OSPF interface. OSPF. All right. And then we're going to look to see who the router is. It says here, the internet address is 10.1.1.30. And the router ID is 11111. What is that? The type of network it is point to point. And there is no designated router. And there is no backup router. Oh, well then, I don't think OSPF must be configured on here. Let's see. Show protocols. Okay, so packet tracer versus GNS3. Show start. So we indeed have OSPF configured, but yet we're getting that there is no designated router, no backup router, and backup designated router. Why? Because the priority is set to 0 by default on serial interfaces. So since we have a priority of 0 on serial interfaces, you will not have a backup or designated router, okay? Even though it's on a point-to-point, because that's what your book says. On a point-to-point network using OSPF, the backup designated router will be the IP address with the highest IP address on any physical interface, unless there's a loopback configured. And indeed, ladies and gentlemen, we do have a loopback configured, which is a virtual interface used for testing or election process. And as you can see, that is the router ID. So a DR or BDR does not exist, but a 1.1.1, which is on this router right here, and we'll verify it by doing a show IP in brief. All right, you can see that this is indeed a loopback 1.1.1.1. So therefore, the router ID for this one is this. But if you go to this particular router and you do the same exact command, show IP OSPF interface S0/0/0, and you see that the 222, the loopback address, is taking precedence over the physical interface. And that's what it says in the book. In an election process, which here you see there is no designated router or backup designated router, but it is choosing to use the loopback interface as its router ID because it will prefer to use that instead of the highest IP address on any physical interface. Why is that? Because loopback addresses do not go down. They're virtual interfaces. Where physical IP addresses, because they're on physical interfaces, or not physical IP addresses, but IP addresses on physical interfaces, those interfaces may go up and down, up and down. You may have a flapping interface. Therefore, that process will always be happening. Always, that election will always take place. So take note. This is what I'm trying to show you. That on serial interfaces, there is no election process for designated or backup designated routers because the priority is 0. Also to take note, that the loopback interface is what's becoming the router ID because it is the preferred, right? Because it's a virtual interface. All right, so let's take a look. Let's close this. Let's close this. And whoa, what a scary background. All right. And let's go ahead and open up this guy right here if it wants to. All right, there we go. All right, so now we're doing on a fast Ethernet interface. You see full loading done, so you know OSPF is already configured. We're gonna do enable. We're gonna do show IP OSPF interface F0/0. Enter. And lo and behold, what does it say? Designated router 33333. Backup designated router 44444. So there is an election process in an Ethernet network. Why is that? Well, let's dispel the mystery. Because the priority is set to 1. Because priorities can be set from 0 to 255. 0 means do not make an election. You will not take part in an election. 1 is the default, all right, for fast Ethernet. So you will participate in an election, and based on the rules of the election, I will choose it should be the highest IP address, should be the designated router, and the lowest IP address should be the backup designated router. The reason that this happens is in the order of configuration. But regardless, it's choosing the loopback interface over the IP address on the physical interface. What are you taking note here? That the priority on an Ethernet connection, point to point or whatever, it's going to have a priority of 1. So since you have a priority of 1, it's going to say, hey, whatever interfaces are on here, or if they're Ethernet, they're going to take part in the election process. All right? And that you will go ahead and get a backup designated router and a designated router, okay, 33333, whatever the case may be, all right, over the physical interface, but not on a serial point-to-point. Keep that in mind, and you can see that the type of network here is broadcast, where up here it was point-to-point. Here is broadcast. All right, so now you know the difference between serials and on a point-to-point connection, which indeed will have an election. All right, so what we're going to do is go to our other example over here. We have a multi-access environment. A multi-access environment. So what we're going to do is we're going to configure, and we're going to do it quickly. We're not going to waste any time. Notepad. All right, we're going to say router OSPF1 network 192.168.1.0. I know I got 1.1 there. 000.255 area 0. And the loopback here is 3. Okay, I believe it's 3. Should have chosen 3. Let's see. Always verify. Always verify. Don't leave anything to guess because you're taking a certification. Show IP in brief. And you're not going to have, yeah, it's 1.1.1. You see that? I would have made a mistake. Huge mistake. All right. Here we go. And then you go net 1.1.1.1. 0000 wildcard mask area 0. That is your loopback interface. So we'll go ahead and copy this. Control C. We'll go to our router. We'll go to config T. And we'll just paste. All right, hit enter. Do WR. That is awesome. Now we're going to come over here. Now let's see what I chose for a loopback over here. Show IP in brief. I chose 22222. So I'm assuming this is 2223, 4444. Okay, so let's go to Notepad. And all we need to change, because this network stays the same, so the only thing that's going to change is this right here to 2.2.2.2. And let's create a couple enters here. Well, let's do this. Type less. Do WR. And people will hate you for doing this, but hey, this is what's called efficiency. Control C. go to the router, global configuration, and then just paste. Done deal. Awesome. We should get a loading done, but we'll see how long that takes. All right, then we're going to go to this router right here. We already know that's going to be 33333, but we're going to verify it anyway. 3.3.3.3, because in a multi-access environment, you will have one designated router and one backup designated router. So let's go ahead and copy that. Control C, but I'm going to verify. Even though I've copied it, I'm going to verify before I paste it. Always verify. Show IP in brief. And it is indeed 3.3.3.3. I'm going to do config T, and now I'm going to paste. All right. Now we're going to go to our last router. Let's just verify since we're there already. Let's do a show IP in brief. And this is 44444. Awesome. So all we need to do is change this configuration right here, which is our loopback interface, our virtual interface, used for testing purposes, or for this case, for election process. So this is going to be the router ID, Control C. And then we go into the router, go to global configuration. All right, and then we just paste. All right, cool. So that's done. Show IP route. And lo and behold, it's not working. Isn't that great? Well, this is all part of IT, is it not? Yep, there we go. OSPF is not the quickest. BGP is slower than OSPF, but hey, we make do with what we have, right? That's one of the things you learn in IT is patience, patience, patience. There it is. We're learning about the 1, we're learning about the 2, we're learning about the 3 because we're the 4. Okay, so OSPF is working, but what we need to know, hey, who is the designated router and the backup designated router on a multi-access network? Well, show IP OSPF F0 or interface F0/0, and you hit enter. So what we have here is, as you can see, there's our priority of 1, so there will be an election, and we have a broadcast type of network because it is a multi-access network. We're all connected to one switch, one broadcast domain. And look at this. It's using the loopback addresses. Now the router ID is 44444, but look how weird. The designated router is 1111, and the backup designated router is 2222. Well, why is that? Well, that is because we configured this first, and then we configured this. It said, hey, I'm the only one on this network, so I'm the designated router. And then this guy came up and said, hey, I'm the second guy here, so I must be the backup designated router. And as we went along, everybody just accepted that as the fact. But we're going to change that. We're going to cheat. You would never do this in a real world environment. You actually, there's things you can do to say, hey, you're going to be the designated router, and I'll show you now. But what we're going to do, we're going to just do something that you would never do in a production network unless you're in, maintenance time or something like that. We're going to reload the switch. Well, what happens when you reload the switch? Well, everything turns off. And if everything turns off, then everything recalculates, right? It's like everything went down, everything needs to come back up. Now, other things, the next thing that we're going to do, which really is the best way, Cisco recommends really to hard code the router ID, all right? But if you want to make sure who's going to be your designated router, which is usually your router ID, but because I'll trump everything, I like to use the priority number, and that's what we're going to use next. We're going to use the priority number of 255 that states, hey, I am the designated router. Any number below me will be the backup designated router. So we're going to designate a particular router as a designated router by changing the priority on the interface. And then we'll put one for 255, we'll do one for 254, we'll do the extremes, and you'll see how that would change immediately. All right, so let's go back again to our famous router over here. Let's see, we got the full loading done. Let's make sure we got show IP OSPF interface F0/0. Let's see what happened. And voila. Now we're using, as you can see, the router ID is 4444 and the designated router ID is 4444. So that's why the router ID, if you hard code it, if you put it in or the OSPF configuration, that will make it the designated router. But we're going to use priority numbers. So you can see that it's still choosing the loopback interfaces to go ahead and use them as your backup or designated. Now remember, the designated router will use a 224.006 where it sends updates from. Everybody else will use the 224.005 to send its information from, because OSPF does have two multicast addresses that it uses. Okay, so based on the rule that use the highest IP address on any physical interface unless there is a loopback address assigned, then you will use that, because virtual interfaces do not go down. Therefore, you will not get any flapping interface when that's concerned. But what we're going to do is that we're going to go back and we'll make this router here the designated router, and we'll make this router here the backup designated router. So let's go ahead and go into its interface, right? The interface F00. So we're going to escape out of here or exit. We're going to interface F0/0, and we're going to say IP OSPF priority, and we're going to do 255. That's going to be the designated router. Do WR. And we're going to go to the other router, Fast Ethernet 00. Okay, because that's just the way we are. That's the way we want it to work in our network because of our design. Whatever the case may be. Beefy router, who knows? Because remember, the reason for the designated router, everybody sends to the designated router, and then the designated router updates everybody else. That's the whole point. All right, so we're going to go to interface F0/0, and then we're going to go IP OSPF priority. I tab a lot, so I turn to do a lot of misspelling. Priority 254, one less. Do WR. Alrighty. And let's see if it changed automatically. Let's go back to our router over here. Or we have to do a little trick again. I'm just going to up arrow, really. Up arrow, there we go. Now it's still telling me the same thing, so let's do a little dirty trick that we normally wouldn't do. Alright, this is the switch. And we're going to reload. Danger, Will Robinson. You don't want to do that in a production network, but there's a lab environment. And the whole point that I'm trying to show you is that you do not, or you can manipulate the election. You can manipulate the election. Serials, no elections, because priority is 0. Fast Ethernet, there's an election, because it's Ethernet. So the priority is 1. And then you have an election. Then and also the order of how you configure will make that one designated or backup designated. And we can then go into the interface and say, hey, we want that particular router to be the designated router, and we want the other router to be the backup designated router. So everything is green again. Let's go in here. Let's make sure we have full connectivity. Show IP route. Not yet. OSPF is taking a sweet time. We just keep doing this. There we go. Until it starts loading everything up and still has not. Come on. Let's wait. It sees its own loop back. Let's go over here. Let's see what this router's got. See full loading done over here. Drive your route. It's got some stuff over there. Okay. Let's go over here. Let's try it again. Swipe your route. There we go. We got the 1, the 3. The 2 is the one that's taking quite a bit of time to show up. Come on, 2. Swipe your route. 2 is being stubborn. All right, swipe your route. Okay. Let's go back to this guy. Still is not getting the 2. But let's see. Let's go to this guy. And let's do a show IP OSPF interface F0/0. Let's see if anything's changed. Let's maximize the screen. And what are we looking for? Is now, oh, look at that. Router ID 2222, or the designated router 2222. And the other one is 1.1.1. Why? Because we changed the priority. We changed the priority. And the 1.1.1, we know it's this one right here. Okay, so we do a show IP interface, show IP OSPF interface F0/0, and you'll see that you'll have your designated or backup designated router is 1.1.1, and then your designated router is 2.2.2. And because of the priority that we changed, all right, that's all it takes. I'll see you in the next.